All right, well, we're looking at arithmetic sequences, and we know that arithmetic sequences are characterized by a sequence of numbers that have a common difference. And now we're being asked to find both an explicit and a recursive formula for the nth term of an arithmetic sequence. And I think it's probably helpful if we discuss maybe what a recursive and an explicit formula do, or how we would use them, and what form they would take. And let's start with a recursive formula. Now, a recursive formula, we would use a recursive formula to help us find sequential terms of a sequence. In other words, if we started with the first term, we solve for that, and then we plug that into the formula and find the second term, and then the third term, and so on and so forth. And a recursive formula is going to take on this form. We're going to be, most of the time we'll be given A1 equals, let's just say X equals a number. And then we're going to be given the formula, which is AN equals A n minus 1 plus the common difference. All right, and that would be a recursive formula, and that would help us find sequential numbers. Now, an explicit formula, what we would use it for is to find a given term. Let's say that we were asked to find the 14th or the 25th or the 39th number of a sequence. Well, if we use this recursive formula, we're going to be doing a lot of calculations to try to find the 25th term. But an explicit formula, we could just plug in 25 for n, and we could solve it and get in that example, the 25th term of a sequence. And an explicit formula is going to take on this form, be AN equals A1, this is how we solve it, plus n minus 1 times the common difference. And then we solve that and we come to an explicit formula. So now, having said that, let's see, we're being asked to find both an explicit and a recursive formula for the nth term of the arithmetic sequence 35, 23, and 11. So the first thing we got to do is find the common difference. Well, if I subtract 35 from 23, I get negative 12. And 11 from 23, 11 minus 23 is also going to give me negative 12. So my common difference is negative 12. And with this information, we can then write both an explicit and a recursive formula. So which one we want to start with first? Well, let's start with the explicit. So I would start here with an AN equals, and I would substitute in for A1 here, the first number of this sequence, 35, plus n minus 1 times the common difference, which is negative 12. I want to put that in parentheses, make sure I'm not trying to subtract negative 12. Well, let's distribute negative 12 to n minus 1. Then we would get AN equals 35 minus negative 12 times n is going to be negative 12n. And negative 12 times negative 1 is going to give me plus 12. Now I'm just going to combine like terms, the 35 and the 12, and then I got AN equals negative 12n plus 47. And that is my explicit formula for this sequence. Now, how about the recursive formula? Well, we're going to start like this. We're going to say A1 equals 35, and then AN is equal to A n minus 1 minus plus my common difference common difference is negative 12, negative 12. And that's my recursive formula. All right, it's not too bad. Just got to keep your head on straight. Line upon line, precept upon precept. Here a little, there a little. Shazam!